Moving on to PWM content in our PIC18 microchip. PWM is pulse width modulation. Pulse width modulation mode produces a PWM output at 10-bit resolution. PWM output is basically a square waveform with a specified period and duty cycle. So you can see here, this is duty cycle from this edge to this edge, and period is from starting edge to the end or another starting edge. PIC18 is a microcontroller that has two CCP modules. Each module has two 8-bit registers. Module 1 has CCPR1L and CCPR1H, and similarly module 2 has CCPR2L and CCPR2H. Each register pairs a form of 16-bit registers that can be used to generate waveform with a specified duty cycle. So for module 1, the register will be CCP1 controller. Module 2 is controlled by CCP2 controller, CCP2 con. So we'll move to analog to digital converter. Analog to digital converter is an important component for every microcontroller. Its function is to convert analog input voltage to digital numbers, so it can easily be read by microcontrollers or any other digital devices or systems. So this is the analog configuration for PIC18 microcontroller. So the channel will be AN0 to AN7, and voltage reference is taken from positive voltage reference is taken from AN3 port, and negative voltage reference is taken from AN2 pin. The analog to digital converter has four registers, which is ADRESH, ADRESL, ADCON 0 and ADCON 1. ADRESH and ADRESL store the higher and lower result conversion respectively. The ADCON 0 and ADCON 1 module is used for clock conversion. ADCON 0 controls the operation of selecting clock conversion, and ADCON 1 is used for selecting an input channel and starting powering up or shutting down analog to digital converter. ADCON 1 is used for selecting the conversion format, and ADCON 0 is used for selecting reference voltage and clock conversion. So this table refers to select clock configuration. So you can see the binary number values which you can edit to our ADCON 1 and ADCON 0 registers to get respective clock conversion. This table refers to port configuration. This channel A refers to analog, D refers to digital. So AN, when you have voltage reference, you can set the binary numbers according to the configuration. in the registers.